In MCQ 10, we'll shift our focus to plants itself, this time around looking at the kind of substance that utilizes stomata to enter the leaf. Now, to enter the leaf itself, you have a few entrance points. Now, definitely we have stomata, which is found mostly concentrated on the lower epidermis of the leaf. And from this, we're looking at the entrance of CO2 to support the process of photosynthesis. We can also see the release of O2 known as excretion, because this is the waste product of photosynthesis. But O2 itself can actually be taken in should the plant actually have to undergo aerobic respiration, which by the way takes place all the time. Now, other routes here that we're looking at will actually comes from the stem itself. Now, doing a little bit of a cross-section of the stem, you'll see that in the middle of the stem, you should be looking at your vascular bundle. So the first vascular bundle here in blue, which is in and near to the core of the stem itself, this is actually the xylem, whereby the transportation will actually be the water moving into the leaf, very critical for the act of photosynthesis, as well as mineral salts will actually be entering the leaf itself. Now, some of the mineral salts here that is critical for you to remember will include things like potassium ions that is helpful for the opening and closing of the stomata. We have the nitrate ions that actually combines with glucose to give you amino acid. And lastly, magnesium ion that is necessary for the synthesis of your chlorophyll. Now, in pink, on the peripheral of the stem itself, this is actually known as the phloem. And we are looking for glucose. My mistake. We are looking for sucrose transportation, as well as amino acid transportation. Now, the act of having sucrose and amino acid is more of it transporting away from the leaf rather than entering the leaf itself. Unless the leaf is actually dying, having some inability to go through photosynthesis, then sucrose from the other leaf will actually be transported to it. Now, a side note here for sucrose is that although glucose is the monosaccharide that we're forming, we'll convert it to sucrose because it's considered to be a non-reducing sugar. So this actually makes the process on the phloem via translocation to be relatively much more simple, as it's unable to interact with the walls of the phloem, which might affect the amount of glucose that is being transported to the area itself. So I will not go with B as well as C, because both of this itself is actually transported via the vascular bundle, to include D as well, transported by the vascular bundle. Now, glucose will be actually converted to sucrose and transported on the phloem itself, whereas mineral salts and water will actually be transported on the xylem. So the answer is going to be A. Carbon dioxide enter via the stomata, and this actually reaches the palisade and the spongy mesophyll layer to facilitate photosynthesis.